ever really thought about how a huge, modern factory actually works? I mean, it's not just a bunch of gears and robots moving around. It's actually a silent, super high-speed conversation happening between hundreds, sometimes even thousands, of machines. Today, we're going to pull back the curtain on this hidden world of machine communication that literally powers everything we use.
Okay, so let's get right into the big question. You've got the brain of the factory. That's your central computer system. And then you have the body, all those individual machines doing the actual physical work. How on earth do you get them all on the same page, speaking the same language, so that everything runs perfectly without descending into total chaos?
Well, the answer is something called a communication protocol. The easiest way to think about it is like grammar, but for machines. You know, without grammar, our sentences would just be a jumble of words. It's the same for computers. Without a protocol, their communication is just a meaningless mess of zeros and ones. The protocol makes sure that when one machine speaks, the other one knows exactly what it's saying.
And you know, getting this right isn't just about being efficient. It is absolutely critical for safety. Just imagine a giant robotic arm or a motor spinning at thousands of RPM. As our source material points out, one single misunderstood signal, just one mishearing, could lead to a catastrophic failure. So these protocols, they have to be completely rock solid. No room for error. But here's the thing. For decades, there was a massive, massive problem. Instead of having one universal language that every machine could understand, the factory floor was like a digital Tower of Babel. It was just chaos. To give you an idea of how big this problem was, let's look at PLCs. That stands for Programmable Logic Controllers. Basically, they're the tough little computers that act as the brain for each machine. And get this, there are over 122 different companies making them. And if you thought that was a lot, it gets even crazier. Between all those companies, they created more than 345 unique types of controllers. So here's the real kicker. For years, pretty much every single one of those manufacturers developed their own secret proprietary communication language. What did that mean? It meant that if you bought a machine from one company and another machine from a competitor, getting them to talk to each other was a total nightmare. It was nearly impossible to build a truly connected factory. So how did we end up in such a mess? Well, to really get it, we need to look back at the history of the two main types of controllers, CNCs and PLCs, because they grew up completely separately. This timeline really tells the whole story. You've got CNCs, which control really complex tools with incredible precision, and they were born out of military needs way back in the 50s. Then, almost 20 years later, you have PLCs, which were invented for a totally different reason, to replace these big, clunky relay panels in car factories. They evolved on completely separate tracks for totally different purposes, and each one developed its own private little language along the way. So, by the time the 1990s rolled around, the industry was just desperate for a solution. The cost and the headache of trying to get all these different machine languages to work together was holding everything back. The stage was set. We needed a common tongue, a universal translator for the factory floor. Now, this solution didn't just appear overnight. It happened in a couple of major steps. The first big leap forward was a protocol called Modbus, way back in '79. It was a true game changer because it was the first real attempt at an open standard that anybody could use. It was a huge step, but it was still a bit rigid. The real breakthrough, the one that changed everything, was something called OPC, which eventually evolved into the modern standard we call OPC-UA. This was the lingua franca everyone was waiting for. It's flexible, it's secure, it works on any platform. It's pretty much the perfect language for a modern smart factory. So, what's the big takeaway here? With a universal language like OPC-UA, you can finally connect every single level of a factory, from the business software running in the front office, all the way down to the individual motors spinning on the factory floor. This diagram shows exactly how it all fits together. Right at the bottom, at level 1, you've got the PLCs and CNCs that are physically controlling the machines. One level up, you've got the systems that supervise them and collect all the data. Level 3 manages all the day-to-day factory operations. And way up at the top, level 4, is the software that handles the business side of things. OPC-UA is the spine that connects all of it, letting data flow up and down seamlessly. It is the key that finally unlocked the truly smart factory. It's pretty incredible to think that for decades, our most powerful tools couldn't really understand each other. But now, they can finally have a real conversation. And this breakthrough isn't just about making factories more efficient. It's about building the foundation for a whole new era of intelligent, coordinated automation. Which really leaves us with a fascinating question to chew on. Now that our machines can all talk to each other, what will they decide to build next?